Back when Apollo missions were launched, astronauts returning from the moon claimed that moon dust, the gray sand-like dust covering much of the satellite's surface, smelled and tasted – yes, they actually tasted it – like gunpowder. But the stuff moon dust is made of is nothing like gunpowder. About half of its composition is silicon dioxide glass from impacts with meteorites. They hit the surface of the moon at incredible speeds. Whoa! The high temperature makes the topsoil fuse into glass, and the impact shatters it right afterwards, creating the gray and clingy dust. The rest of moon dust ingredients are minerals such as iron, calcium, and magnesium, while old-fashioned gunpowder consists mainly of saltpeter, charcoal, and sulfur. In other words, moon dust shouldn't smell like gunpowder, but it does. Besides, when astronauts brought samples of it back to Earth, there was no smell left at all. One explanation could be that the moon is similar, in a way, to Earth's sand deserts, like the Sahara. It's extremely dry and arid. When you sniff the air in a desert, you don't smell anything. But if you get caught in the rain there, the moisture will raise all kinds of odors from the ground that were previously trapped in the dry sand. With moon dust, it might be similar. While on the surface of the moon, it doesn't smell at all. Not that the astronauts could sniff at it wearing their spacesuits, though. But when brought back inside the landing module, the dust came into contact with moisture in the air and started emitting its strange odor. Another reason for this could be a reaction of moon dust to the solar wind. Ionized particles from the sun hit the bare surface of the moon and stay there. There's no thick atmosphere to protect it from those ions, so they travel freely right to the ground. They're very lightweight, so they can fly off and sort of evaporate from the slightest of nudges. And when astronauts took the moon dust samples to the landing module, those particles could have started moving around and giving off the specific smell. This might also explain why the samples didn't keep their odor when brought back to Earth. Since the particles are so light, they might have flown off the samples already in the landing module, and when they were placed in airtight containers, there were little or no ions left on them. Another explanation is that those airtight containers weren't so airtight after all. Moon dust is basically very small crystals with extremely sharp edges. They unexpectedly made tiny cuts in the seals, letting in air and moisture, and so the ionized particles leaked out of the containers. Scientists believe they should study moon dust on the surface of the moon itself to find out everything about its properties. Now, there are hundreds of thousands of craters on the surface of the moon made by falling asteroids, but one of them drew a lot of attention. It turned out to not be just an impact crater, but a tube, looking most like an entrance to a cave system. Scientists found a specific echo pattern that suggested there was a hollow area beneath. They discovered more echo patterns at a couple of places near the hole, so there could be more lunar tubes there. But in this big tube, you could place an entire football field. Researchers believe there could be an entire geological wonderland under the surface. It could be a good shelter for astronauts landing on the moon, or even be a harbor for a lunar colony. No one ever managed to stay on the moon for more than 3 days because of the conditions on the satellite. Wide range of temperatures, low atmosphere, no magnetic field would protect life on the surface from things like radiation or solar wind. Astronauts wear spacesuits. They can't protect them over long periods of time, but a lava tube could. When a lava flow cools, it gets a hard crust, which later thickens and creates a roof over that same lava. It continues to flow, but when it stops, the channel can drain, and that's how an empty tube appears. Our planet also has lava tubes, but they're not as big as the one found on the moon. Back in 1178, I wasn't around then, at least 5 people in England claimed they had seen the moon split into 2 from its upper tip. It was in the shape of a crescent at the time of the event. When the crack widened, fire started blazing from it, which the single monk who chronicled it described it as a flaming torch sprang up, spewing out fire, hot coals, and sparks. Then the moon started shifting around and pulsating, but soon stopped and turned a slightly darker shade. The event didn't receive much attention from scientists, though, until the second half of the 20th century. Researchers studied the chronicle and figured out there was a huge 14-mile-wide crater on the surface of the moon at about the spot described in the book. Only a very large asteroid could have left such a scar on the satellite's face. And when they investigated it more closely, they found out it was pretty recent by astronomical standards. In fact, it really could have appeared about 800 years ago. But in that case, millions of fragments from the asteroid and the moon would have hit the Earth as well, and then people would have seen an incredible meteor shower. It would have been very bright, and the memories of it would have definitely been in the archives. But that didn't happen. In addition, many scientists argue that the crater isn't as young as it might seem. The most popular and justified theory is that it's about 1 to 10 million years old. If it had appeared as recently as 800 years ago, parts of the surface of the moon in and around the crater would still have been warm from the impact. The most likely explanation of what really happened back in 1178 is that observers were extremely lucky to see an asteroid falling towards the Earth and burning in our planet's atmosphere. The spectacle would have been incredible, and seen from a proper angle, the burst of the asteroid could have really looked like it was the moon exploding. That would explain why there were so few witnesses of the phenomenon. The right spot to see the show, as they did, was only a couple of miles wide. As for real events on the moon, water and oxygen were unexpectedly discovered on it not long ago. Water might have been brought to the satellite by asteroids hitting its surface, many of them carrying H2O molecules, and those that are left on the moon in tiny amounts after the impact. There's precious little water there, though. By comparison, even the Sahara Desert has more of it than the entire moon. Oxygen is also present as separate molecules floating around, so you still can't breathe on the moon. Solar wind brought them there. Waves of energy from the sun travel at extremely high speeds through space, scrape oxygen from the upper parts of our atmosphere, and carry it further. Eventually, the wind with the oxygen molecules reaches the moon. And that's where something incredible happens. The moon starts rusting. There's plenty of iron in the lunar soil, and when it's exposed to oxygen and water, it naturally rusts. Some parts of the moon have actually already turned slightly reddish. They're regions where there's the highest concentration of molecules. If this process goes on long enough, in the distant future, the moon will look like Mars. It will turn orange-red. Yes, the signature color of Mars came exactly from the corrosion that began there thousands and thousands of years ago, when there were rivers and seas with water and an atmosphere with oxygen. Another unusual phenomenon is the blue and red lights on the moon. They can be seen when it's crescent-shaped. The flashes come and go very quickly, almost like lightning. And in fact, that's what they basically are, electric bursts. Tidal forces are to blame for this. They cause mechanical stress buildup in the rocks. This can produce an electric field, which creates the blue flashes that have surprised many amateur astronomers. But still, there's so far been no green cheese discovered there, or moon pies for that matter. Disappointing, I know.
You wake up, and a sharp smell of rotten eggs hits your nostrils. You look around wildly and realize the smell isn't coming from your mom's cooking downstairs. It's super hot, and there are giant red clouds churning in the sky. Yikes! You're on Venus! The planet is named after the ancient Roman deity of beauty and love, but sadly, its smell doesn't correspond with its name. The atmosphere of Venus is made up mainly of carbon dioxide, but thick clouds of sulfuric acid completely hide its surface from prying eyes. Sulfur has a really bad stench, which causes the surface of Venus to smell like rotten eggs. Gross! The atmosphere on the planet is also really hot and thick. The carbon dioxide traps a small amount of energy from the sun that reaches the planet's surface. This greenhouse effect has made Venus one of the hottest places in the solar system. So, the good news is, you wouldn't be able to smell the planet's stench, as humans can't survive on its surface. Well, that's a relief. Almost all other planets in our solar system only have a super small selection of different scents on their surface, unlike Earth. But what about our moon? The scent of the moon is similar to something called smokeless powder, which is a propellant used in firearms. Basically, the dust on the satellite smells exactly the same as when a shot is fired. Apollo 17's pilot Eugene Cernan says he could smell it straight after removing his suit from the spacecraft. But nobody's exactly sure why it smells like this, as there's zero similarity between the two substances. Smokeless powder is made up of a mixture of two things with very complicated names: nitroglycerin and nitrocellulose. Black powder, its older counterpart, is made of charcoal, saltpeter, and sulfur, which makes it smell in a very specific way, but not like rotten eggs, despite the sulfur content. Moon dust is made up of a bunch of things that primarily come from broken meteorites. This includes iron, magnesium, and calcium, but it doesn't contain either of the things in smokeless powder, or black powder either for that matter. And what's weirder is that moon dust samples brought back to Earth have been odorless. Experts say the smell could have been the dust reacting with oxygen or water inside the lander. The smell could also be due to the temporary release of charged particles from the sun that had become trapped in the dust. Mercury is the planet closest to the sun, but it doesn't really have a strong smell. This is because the atmosphere is so thin and scattered. Mars. Like Venus, it's another world that doesn't have the best scent ever. It's a good thing we can't breathe its air. The red planet smells like rotten eggs, again caused by sulfur. If human colonies did move to Mars, it looks like we'd have to burn a lot of scented candles to cover the smell. But the good news is that the sulfur quantities are pretty small, so the smell wouldn't be too overwhelming. Jupiter also has a whiff of eggs, but also smells a bit like it's been mixed with cleaning products. This is because its atmosphere is a mixture of hydrogen sulfide and ammonia. But what you smell basically depends on where you are in the planet's atmosphere. Some regions have higher concentrations of ammonia. This substance is used in a bunch of cleaning products here on Earth. So areas high in ammonia could have that strong burning stench of cleaning fluid. A lot of people also say that ammonia smells like a pair of dirty socks that haven't been washed in forever, so it's for sure best to avoid these parts of the planet. Other areas have a lot of hydrogen sulfide, and because it contains sulfur, these parts would also smell like rotten eggs. The third and final scent you'd find on Jupiter is bitter almonds, or marzipan, just like the kind your grandma puts on cakes around the holidays. This is in areas where a substance called hydrogen cyanide is most common. Jupiter is the biggest planet in our solar system. It's so big that it's 2.5 times larger than all of the other planets in the solar system combined. It's also the fastest spinning planet in our solar system. Next up, the ringed planet, Saturn. Its atmosphere is made up of about 96% hydrogen and 4% helium. Yes, that's the gas that makes your voice go all squeaky. Both hydrogen and helium are odorless, so Saturn probably doesn't have a strong smell. It does, however, contain traces of our good friend ammonia. That's the smelly sock gas. Saturn's atmosphere also has a bit of phosphine, which can sometimes smell like garlic or decaying fish. So there might be a slight bad stench in the air. The thickness of Saturn's atmosphere is only 37 miles. For comparison, our atmosphere here on Earth is almost 300 miles thick. Saturn also has some of the strongest winds in our solar system. They can reach a whopping 1,118 miles per hour. One of Saturn's moons is called Titan, and it has a super odd scent. Its atmosphere is made up of something called benzene, which has really weird effects if inhaled by us humans. It can make us feel dizzy and make our ears ring. It doesn't actually smell that bad though. Its scent is kind of like almonds. Now it's time to take a dive into Uranus. This gas giant has gotten itself a reputation as the smelliest planet in the entire solar system. There's a lot of stinky stuff floating around on the planet, and its upper atmosphere is made up mostly of hydrogen sulfide. Yep, that's the molecule that makes rotten eggs smell so nasty. But the temperatures are so severe on Uranus that you'd pass away even before you've had a chance to smell anything. Uranus's atmosphere is a staggering negative 392 degrees Fahrenheit. That's so cold that it would almost instantly freeze anyone. The final planet in our solar system is Neptune, and it's just as cold as Uranus, at negative 373 degrees Fahrenheit. Neptune also smells pretty bad. Some scientists say it smells like seaweed that's washed up on the shore. Others say again that it smells like rotten eggs because it contains a bunch of hydrogen sulfide molecules. But like on Uranus, you're not going to have time to take in the nasty smell. As the most distant planet from our sun, it's dark, freezing cold, and has supersonic winds. No one would be able to survive when faced with one of the icy hurricanes which are constantly raging on the planet. Neptune is the only planet in our solar system that's not visible to the unaided eye. Well, we've covered the planets, but what does space itself smell like? Space is mostly a vacuum, which means it doesn't actually contain any molecules, so there's basically nothing to smell. But some astronauts have actually said space smells a bit like fried meat or hot metal. This smell is most commonly reported in the first instance after the astronauts re-enter their spacecraft. They shut the airlock, repressurize, and then remove their helmets. But there are a bunch of theories suggesting that the meat smell isn't actually space. It's either from the equipment operating the airlock or from interactions between space particles and the spacesuits. Astronaut Tony Antonelli said that space definitely has a smell that's different than anything else. Talking about his fellow spacewalkers coming into the ship, another astronaut, Don Pettit, said he noticed that this smell was on their suit, helmet, gloves, and tools. One thing we definitely know that has a smell, though, is comets. If you could inhale a big whiff of a comet, it's likely going to make you feel lightheaded and maybe even sick. The odor from comets is like a mix of rotten eggs, old smelly socks, almonds, and it'll also have a hint of biology dissection lab. On the bright side, though, the presence of hydrogen sulfide and sulfur dioxide in the scent would block your sense of smell after the first sniff. So at least the stench wouldn't linger. But the bad news? Nearly all the ingredients that make up a comet's smell are toxic. So you're probably going to want to avoid coming into contact. How much would a pinch of sand be worth to you? How about without the elements of gold or platinum mixed into it, just moon dust? A recent auction sold it for $500,000 for literally just a pinch of what's on the moon. But this apparently valuable minuscule amount of dirt was valued purely on its historical relevance. That pinch of sticky moon sand was from a small pouch that was collected by Neil Armstrong on the Apollo 11 mission in 1969. It was a huge piece of human history and a physical reminder of when man first landed on the moon, something taken from a place that no one else has ever been able to. Selling something from the moon opens a whole new debate around the legality of owning, using, and selling space resources from unclaimed parts of the solar system. Currently, the world abides by the 1967 Outer Space Treaty, which depicts the foundations of modern space law. This treaty, established so long ago, didn't predict the lucrative use of outer worlds for resource utilization. Although this treaty prevents anyone from claiming ownership of any new worlds, the potential value of these unclaimed territories is priceless. The moon is not only a stepping stone for future exploration into outer space, from which moon bases and possibly moon cities will one day thrive. For this purpose, humans will need to develop shipping bays and factories to support carriers to cross into new worlds. This project will need some good investments. Mining stations will provide the economy of the hypothetical moon city. There will be infrastructure and transportation to the moon and back again. All of this will cost a lot, way more than a reminder of when man first walked on the moon. So, apart from moon dust, what else could be valuable on the moon? There is value in the resources on the moon. We don't know the exact numbers, but it's estimated that there is more than was thought in the past. The Earth's natural satellite is believed to be abundant with iron, nickel, and cobalt, amongst many more. These minerals provide the potential for building Moon City itself. Just as in human history, cities around the world are a reflection of what resources are in abundance in their surroundings, and Moon City will be the same in that way. A gray city, walls made with metal, iron dust, and a lunar sand concrete, with great windows made from the unlimited sand available. The moon is also rich in silicon, an important ingredient in producing solar panel arrays. There's calcium to be used to fabricate the silicon-based solar cells, along with other ingredients found there, like titanium oxide, iron, and aluminum. The long dormant lunar magma ocean residing under its surface holds magnesium. It's especially prominent within the lower crust and is useful for many purposes, most importantly for alloys with expected space travel. The production of steel requires many sources of carbon, crucially important for supporting the mega factories and for the many thousands of ships that will be built. Numerous rare earth materials are used in everything electrical. They continue to be more valuable, and their production is more prominent as technology progresses, especially in electric vehicles and wind turbines. Although rare earth materials are abundant on our planet, you won't find them in many concentrated areas. They are spread thin throughout the Earth, so locating and mining them is pretty costly, though they're more required with every year. The process of finding and mining on the Moon is far easier and will be an important alternate source. Nitrogen, along with carbon, are important elements to support human colonization and farming, and ensure that the Moon is not only habitable, but has a constant supply of food. We can obtain them within the Moon's outer crust, so farming is possible there within sealed biospheres. Mining metals is a difficult process, but the result is worth it, not only for their value, but also because of the valuable byproducts that you can get in the process of extraction. It can be oxygen, available for breathable air within the city, and hydrogen to ensure water for the plants and for drinking. Valuable resources will not only come from within the surface of the Moon. Its potential for solar power is so huge, it will ensure harvesting the solar waves to power Moon City. The fact that it lacks a thick atmosphere and that there's no interruption of weather patterns removes some major obstacles that are present on Earth. The energy created could be sufficient for all requirements on the Moon, and, in the short term, may also help solve many of Earth's power concerns. Extracting resources and manufacturing requirements will be significant as time carries forward. As Moon City is going to grow, and humans will reach further into outer space, it will require more and more energy. The output to factories and production on the Moon will become so elaborate that they will need alternate sources in reserve. Atom-powered fusion will be an important source of energy with no dangerous byproduct. It will be safer than the technologies of today that use uranium. Feeding this kind of fusion will require the most valuable of all resources found on the Moon, helium-3. It's not only present on the Moon, but can also be found on Earth. But the amount is super limited here due to our planet's strong magnetic field. It ensures life can thrive on Earth, but at the same time deflects the solar winds from the Sun, making it difficult for helium-3 to be produced. The Moon has no magnetic field and has been absorbing the solar wind for billions of years, constantly building up an endless supply of helium-3 in the process. It absorbs the winds into the top layer of solid material on the Moon, also known as the regolith. The regolith is spread all over the Moon, and it makes the extraction of the helium-3 an even more valuable action. Mining it would also include mining all the other valuable minerals in the process. The value of helium-3 is so substantial that many countries and companies are determined to gain a foothold on the Moon. The value of this alone is within trillions of dollars. Some people believe the opportunities that helium-3 will give humanity are immeasurable. There will be unlimited energy providing millions of jobs in Moon City. That energy will also support the Earth's needs. Only 25 tons of helium-3 could power the United States for an entire year. This resource will provide the potential to power all of Earth for thousands of years and have enough energy required to help guide humans further into space. It will enable the construction of spaceports around Earth and allow for a more efficient journey from Earth to orbit. From there, people will be transferred to shuttles destined for other locations throughout the solar system. The lengths of spaceflight will be reduced significantly, creating more frequent flights toward Mars. Further ports will be erected around its orbit, supporting new colonies to reside on its surface. Mining colonies, with the support of endless energy, will spread throughout the red planet, with more valuable resources residing within its red soil. This new age of colonization in the solar system will cause a domino effect as it continues to push further, advancing with every generation of vessels developed. Travel will get more and more efficient as the Helium-3 will continue to assist in advancing the technology of spacefaring ships. Outposts of all purposes will develop on the moons of Jupiter and Saturn, from researching for potential habitability for life on Europa or Enceladus, to continuing the tradition of extracting valuable resources in every location. The moon will continue to find ways to provide the energy that's needed for terraforming new worlds. It will assist in warming Mars and powering an artificial magnetic field. It will also help with constructing a large reflector that will be able to cool down Venus. All of these will be the foundations for creating further livable locations for future generations of humans, all thanks to that initial source of energy from the moon. It's difficult to put an overall price tag on the moon, even when you know that there is value in harvesting its resources. The value of what the moon dust really amounts to can't be determined by a monetary figure, but by its potential to influence what humans can create as we continue to progress as a species.